So, lesson 3-4, we're talking about arcs and sectors. You guys are going to be able to find lengths of arcs and areas of sectors and circles and be able to apply those concepts to different types of problems, okay? And they're very simple, straightforward concepts. It's more so about how you're able to apply them in the different types of problems that you're getting, okay? So some main formulas that you definitely need to make sure that you know. Two of them I know for sure are in your reference booklet. I don't know about the first two because the first two are very basic and they haven't changed since the first time you learned them, okay? What's the formula for the area of a circle?
R squared.
Say again?
Pi r squared.
Pi r squared. Area equals pi r squared, where r represents the what?
Radius.
For the radius. And the circumference, also known as the perimeter of the circle, basically going around the edge of the circle, is what formula?
2 pi r.
2 pi r. Okay?
Yeah.
Or for you SAT, ACT people, it could also be represented how? Pi d. Because remember, your radius is half of your diameter. So if you double it, you get your diameter. It's 2r. 2r does equal d. All right, of course, knowing those basic things, because they could apply at some point in time in any type of these problems that involve any circles. However, some should be reviewed concepts from your previous class are arc length. Arc length is basically a section of your circumference. Okay, it's one piece, it's one part of the outer part of the circle. And that is represented in two different ways depending on if your angle is a degree or if it's a radian. Okay, so if your angle is a degree, all right, then your formula is theta over 360 times 2 pi r, where r is your angle in degrees. You divide that by 360, and then you multiply it by basically the circumference. It's basically you're trying to figure out what fraction of the circumference it is. However, if your angle is given to you as a radian, then your formula is very simple. It's nothing but r times theta. Okay, your radius times your angle, of course your angle being in radian. Do you remember the formula to convert from degrees to radians, radians to degrees? Exactly. So if you want to, you could just use just the one formula and just convert degrees to radian and then use the r theta. Okay? Questions on that? Area of a sector, again, is a fraction of the area. Is the actual entire piece of the a piece of the circle. Okay, kind of like a slice of pizza would be from a pizza pie. So if your angle is given to you as a degree, you can take basically that fraction of that circle and then multiply by the area of the circle. So theta over 360 times pi r squared. Again, if your angle is given to you as a degree. Or if your angle is given to you as a radian, then the formula is 1/2 r squared theta. Again, where r is your radius and theta is your angle. Of course, your angle being as a radian. Okay? You don't have to know both. However, that is both depending on what you're given. If you prefer not to have to worry about converting here or there. Either one, it doesn't matter what mode you're in your calculator when you calculate it, because it's nothing but you're just dividing and multiplying. It's not like you're taking the cosine or sine or anything of it. Questions about those formulas?
George, you pretty much plug in stuff into the RD or the theta?
Yes. Yes, pretty much. Mm-hmm. And like I said, these are the formulas that you would need to know that you are going to be working with. It really just depends on how you're going to apply them inside of the problems that you're given. Okay? So, we're going to be doing examples from here on out. Okay? Applying those formulas to these different types of problems. And let's take a look at this first one. So, a running track consists of 2 straight segments joined by 2 semicircular ends. As shown, the total perimeter of the track is 1,600 meters. Determine the diameter of the semicircular ends. Okay? So, the total perimeter consists of basically 2 straightaways and 2 curves. The total of that would represent 1,600 meters. Now, if you notice, those 2 semicircles together would form one circle. So we're talking about perimeter of one circle. That basically means that 2 pi r or pi d plus the 2 straightaways, which are how long? 500 meters. So your two straightaways should equal 1,600 meters. Everybody with me? Okay. So again, 2 pi r basically represents the perimeter of a full circle. Now you could have done basically just pi r plus pi r if you wanted to do each individual, but when you add together, it gives you 2 pi r. And then basically to find the diameter, you would need to go ahead and solve for here. Let's make it a tad bit easier on ourselves. What's another way to represent 2 pi r?
Pi d.
Pi d, and since we are looking for the diameter, let's go ahead and use pi d instead of 2 pi r. 500 times 2 is 1,000. So then we'll have this. This is going to equal to 1,600. Pi d is equal to 600. And so then d is going to be equal to divided by pi, which is approximately 191. About 191 meters. Good stuff. Okay, so in this particular case, we applied the concept of circumference in retrospect to perimeter of an entire figure. B, Jason takes 4 minutes and 25 seconds to complete a single lap of the track. Calculate Jason's average speed in meters per second. A very good question that's asked on the SAT. Okay, for those who are going to be taking the ACT or SAT in the upcoming weeks. Okay, what old school formula are going to use to try to figure out Jason's average speed? Distance over time equals his speed, or the rate, how fast he's going. Very good. Remember, distance equals rate times time, so then you can adjust that any version. Since we know he's going around the track and it takes him
265 seconds.
265 seconds, very good. So we know his time. So what is his distance? The 1,600 meters, because that's going all the way around. So 1,600 meters divided by 265 seconds is?
Roughly 6.40 meters a second.
Yes?
6.04.
Oh, did you say that and I just misheard it? I think so. I've been having some issues. 0.4 meters per second. Okay, good stuff. Questions? Let's look at the next one.
AGY?
X and Y are the centers of the circles containing 2 arcs, AB shown. Okay, so basically in this particular picture, we have 2 circles happening. Okay, we have one with the center of X and one with the center of Y. But they both have arc AB. It's just represented differently. We have to find the length of AX. AX would represent what? The radius of which circle? Which circle? It will represent the diameter of circle X. Okay. How could I find that?
Would it be half of the radius?
Half the radius?
No, it's like half.
I don't think you need half of the radius.
Half of the diameter.
It would be half of the diameter, yeah. Half of AB. AX is equal to half of AB. How can I find AB?
It's a triangle.
It is a triangle, and it is a hypotenuse of a right triangle. Which right triangle are we looking at?
Looks like an
AYD.
isosceles.
How did you
Is that
know
the
it's
word?
Oh wait.
Because it's a circle.
Because it's a circle.
Because it's a circle, yes, we know it's an isosceles right triangle. So if AY is 16, then we know that BY is 16, and then we can either use a Pythagorean theorem to find AB, or we can use our special right triangles to find AB.
Special right triangle.
Do y'all remember the thing for special right triangles? If not, this is a great time for us to review for your SAT. What's the rule for 45, 45, 90?
Your length for x, your hypotenuse is x root 2.
This is the makeup, okay? Your two legs are the exact same. Your hypotenuse is one of your legs times the square root of 2. So then AB should be what? 16 root 2. Okay, that's how it works with special right triangles. Pythagorean theorem, when you simplify, you get the same thing. So that means I need to take half of 16 square root of 2. What's half of 16 square root of 2? 8 root 2. That would be the exact answer. So you could say 8 root 2 millimeters. Or you can round it to 3 significant figures, as this is a calculator and non-calculator problem. Off the top of my head, I can't remember which one it is. What is 8 square root of 2 as a decimal?
What's the version for
11.
the other special right triangle that was like 60, 30?
We'll go over that, yeah. For your 30, 60, 90 degree triangles, okay, remember the side across from the 30 is your shortest side, so that could be x. Your hypotenuse is twice as long as your shortest side, and then the side across from your 60 degree angle is x, square root of 3. Now now both of these are given to you on the SAT, but on the ACT it is not. All right, now we have to find the perimeter of the shaded crescent. Perimeter of the shaded crescent, that means we are trying to find this green piece, basically that whole green area, okay? How can we go about finding basically that total green area, like the outline?
You find the give me a second. Find the arc lengths of both of the circles.
You have to find the arc lengths of both of those circles, exactly. All right, because AB is the arc length that has a circle center of Y. This one here, the one on the inside. And then the one on the outside is the arc length for circle X. So you are going to have to find those two arc lengths. Okay? So I'm going to do this down here in green. So I need the arc length for circle Y, AB. And I need to add that to the arc length circle X is AB. Okay? Arc length is what formula?
0 over 2 pi r.
You mean theta over 360?
Yep.
Okay. So theta over 360 divided by, theta over 360 times 2 pi r. What is theta for circle Y? 90. So it's going to be 90 over 360 times 2 pi. What's your radius for circle Y? 16. And then we're going to add that to the arc length of circle X is AB. So then what is the angle for circle X? 180. What is the radius for circle X? Because that's what you found in part A. Very good. Then at this point, you multiply and you add. Can you guys go ahead and do that? What you get?
6.67.
One more time.
60.67.
60.67. So that'd be 60.7 millimeters. All right, so you have your exact answer of 8 pi plus 8 square root of 2 pi millimeters, or 60.7 millimeters. Again, I'm providing both because I don't know if this would be a non-calculator, calculator type of question. Okay? Now you have to find the area of the crescent. How do we go about finding the area of the crescent? The actual inside. All of this. So remember, it's about how you can take the formulas that you know that deal with circles, area, circumference, arc length, sector area, and apply it to these types of problems. How do I take those formulas and apply it to that?
Take the area of the entire circle of the
Which one's the bigger? Is it X or Y?
X.
Okay.
And then I divide by 2, and then find the area of the sector of Y, and then find the area of the triangle, and then subtract that from the area of the sector, and then subtract that number from the area of the X. Those are
Okay. So this is basically what you have here. Okay. You have circle Y, and then you have circle X that also shares basically a part of. It's basically kind of like a concentric circle in the sense of like basically this is circle X here. Okay, and our job is to find this part, the area of this part right here. Okay, now in circle X, if I look in just circle X, you're told that we need to find the area of half of circle X, which would basically be a semicircle. Okay, so we can figure out what's the area of this part right here. That's what this section represents. Okay? Now, we're also told that we need to subtract this from the area of the sector minus the area of the triangle. Okay? And we're talking about sector Y. Sector Y is this part right here. Okay, so that's sector Y. You're saying find the area of that and then take away the triangle. If I take away the triangle, then what's in red is basically this part right here. So we can figure out what is basically that little piece, which is called a segment. This red piece here is called a segment. If we can figure out the area of that segment, then we can subtract that area from the area of half of the circle. And that is correct. Right? So let's figure this out. So we know a semicircle is basically half of a circle. So that's going to be pi r squared divided by 2. What is r for circle X? 8 root 2. So that's going to be 8 root 2 squared times pi over 2. We're going to subtract the area of the sector. The formula for an area of a sector is theta over 360 times pi r squared. What's theta? A little louder. 90 over 360 times pi r squared. What's the radius of circle Y? So 16 squared. Then we're going to subtract that from the area of the triangle. The triangle is nothing but a right triangle. What's the old school formula for the area of a triangle?
1/2 BH.
And we can use that because, again, this is a right triangle. What's the base of your triangle? 16. What's the height? 16. So then this would be the setup to find the area of the crescent. So this is part C. We're trying to find the area of the crescent. Okay, go ahead and work that out for me, please. So what's the answer? 128 millimeters squared. Don't forget your units, especially when you're dealing with area and things of that nature. Okay?
Isn't there like 1 unit penalty per paper?
It is 1 unit penalty per paper, but there's no need to be losing units, penalties, and rounding penalties that we can avoid.
Easy points.
Easy points. Okay? Questions? All right, let's keep tackling some more problems. And let's keep tackling some more problems. In this one, Belinda has made a lampshade with an area of 0.32 meters squared. Its shorter arc has a length of 1 meter, and its slant height is 28 centimeters. And the picture that you see to the left is a picture that represents Belinda's lampshade. Now, it says suppose the material is cut as the difference between two sectors with a common angle theta and a radius of r and big R, which you can see in the picture to the right. That's how they created the lampshade. So far, so good? Okay, we have to show that the area of the lampshade is given by this particular formula. Okay, we're trying to figure out that the area of the lampshade is given by this particular formula. Now, before we get started, there's one thing that we need to fix in this problem before we even do any type of math. The units. Do you see how the slant height of the lampshade is in centimeters, but all the rest is in meters? How do you convert centimeters to meters?
Move the decimal.
Move the decimal point of the centimeters to the left. How many? Twice. So 28 centimeters is the same thing as saying 0.28 meters. Okay, so now that we have that, that's kind of, you see that 0.28 that's in the problem. Okay, so I think now we're going to be on the right track. Always double check to make sure your units are in the same. All your units are the same. So, to show that the area of the lampshade is given by this, how do we figure out how to find the area of the lampshade?
This is the same radius, but we find the arc, the area of arc, the capital R, and subtract it from the area of arc,
So we need to find the area with the big R and subtract from the area of little r. Very good. Okay, so basically we're taking the area of the big sector and subtracting it from the area of the small sector. This is a show problem, so it's all about your steps to go about doing this. Now, the one thing is as well, because we're not dealing with two different variables here, we're dealing with just little r because that's what's in the answer that they want us to do. How can I rewrite big R in terms of little r?
R plus 0.28.
Very good. So everybody see why it's R plus 0.28? Because from here to here, that is lowercase r, but the part of the lampshade is 0.28 meters. Yes? So then the area of the sector is going to be, let's use the radian formula for area of a sector. What's the radian formula for area of a sector?
1/2 r squared theta.
1/2 r squared theta. So the radius of the big sector is r plus 0.28 squared times theta, which is theta in this problem, minus 1/2 r squared theta, literally. Oh no, we are going to have to use the 360. Dang nabbit.
Yeah.
Ugh. Succeed in the problem. All right, so we are going to have to keep this as a degree. I apologize.
I was about to say.
So then the big one needs to be theta over 360 times pi r squared minus theta over 360 pi r squared. Algebraically, what am I going to need to do to that r plus 0.28 squared? We are going to have to FOIL it. Okay? Can you guys FOIL that? Take about 25 seconds to FOIL that. What is it FOIL? R squared.
Plus 0.074.
0.74?
0.784.
0.784.
Like that?
Yes.
So this ends up being What do you notice? How distributed pi is. What do you notice in that long line? Don't you see this theta over 360 pi squared at the beginning and the end? So they can cancel out because one's positive, one's negative. So then you're just left with theta over 360, 0.56 pi r, it doesn't matter where the pi goes, plus theta over 360 times 0.0784 pi. What else do you see?
You can take out a 0.28.
You can take out a 0.28. You could also take out a pi. You can also take out a theta over 360. And then that is how you end up getting to that point. So in the show problem, you want to make sure that you do show yourself actually taking out that 0.28 theta pi, which leaves you with 2r plus 0.28. Now, the beauty about show problems is even if you can't show that area, doesn't mean that you cannot use that area to answer B, C, or D. Okay? So if you couldn't show that part that we just did in the black, you can still use it to find the small sector. Okay? So we can use the small sector to show that theta equals 180 over pi r. How can we do that? Let's go with this. What do you know about the small sector? Do you know anything about this small sector right here?
1 meter.
It's an arc length. That arc length.
The arc length is 1 meter. So use that because that's really all you know at this point. What is the formula for arc length?
Theta over 360
times 2 pi r equals 1.
You know that equals your length, and you know your length is equal to 1. Okay? So use that. What can you do? You know all this is being multiplied together, right? 2 pi r over 1 is the same thing. It's just basically saying 2 pi r theta over 360, right? I can cancel out a 2. I can reduce it, yes. What does that become?
pi r theta.
What am I trying to do in the problem?
Oh,
I'm solving for r?
Theta.
I'm solving for theta. How do I get theta by itself?
Multiply 1 a on the side, and then divide by pi. Pi r.
I say use what you know from the problem. The only thing that you knew about the little arc was its length because that's what they told us from the lampshade. So you use that and it ended up actually being that's all we were solving for. We was basically just solving for theta in the arc length formula. Questions?
Can we use arc length for the like at the top of the lampshade if we were given that measurement? Can you use arc length formula for that too?
To find the one in the top?
Yeah.
All right, so now let's use what we know to find little r and theta. How do we find little r and theta? Use what we know. We know the area of the lampshade, and then you said what?
We solved theta equals pi, or 180 over pi r. So you can solve for r and then substitute and then solve for theta.
Yes. This is nothing but a system. You have an equation that's technically three different variables in here. You have area, you have theta, and you have r. You can't do anything when you have three different variables, but you can do something if you have two, okay? And you already know that the area of the lampshade is 0.32, so you can use that area, plug it in, and you can also use the fact that you know that theta is equal to this, so you can find r. So if I plug in 0.32 for A, I plug in 180 over pi r for theta. I can solve for r now. Okay, go ahead and solve for r. You do have your calculator. Use it to your advantage. And once you find r, take that value and plug it back in here to find your theta. So, if you look at just, first off, this entire fraction, okay, I'm talking about the big fraction with the divide by 360, all that's being multiplied to pi, and all of that is being multiplied to 2r plus 0.28, okay? Now the one thing here, and I'm going to do it over here, and I'm going to end up deleting this later, is you basically have 0.28 over 1 times 180 over pi r times pi over 1 times 2r plus 0.28 over 1. Everybody understands that?
Yeah.
Okay? What happened to your pi's?
They cancel out.
They cancel out. Okay? So really and truly, you're just left with 0.28 times 180 times 2r, and then 0.28 times 180 times 0.28. Okay? And then you have a divide by r for both of them. Okay? So what's 0.28 times 180 times 2r? 100.
200.8.
So you have a 100.8 r. All that's being divided by r. Okay? What happened to your r's? They cancel. And then we can't forget about this 360 that's still at the bottom. I forgot about it, so I had to bring it back. All right. Now we're going to multiply 0.28, 180, and 0.28 again. What do you get? $14. 14.112. Does it keep going? Okay, all that's over r, and there's still that 360 that's in the denominator as well with the r. Okay? All that's equal to 0.32. Okay? If you want, you can even subtract this fraction right here to the other side. That's an option. Then you can multiply both sides by 360r, then divide both sides by whatever is attached to the r at that point. Either way, if anything, this is a little bit nicer than a fraction within a fraction being multiplied and then all that other stuff as well. What does r equal for those who did get it? 0.98. Now you could have done it using your calculator as well. You could have put the left side into y1, the right side into y2, seeing where they intersected, and that would have given you your r as well. Or you could have simplified this another way, but it still would have been 0.98. If r equals 0.98, then what's 180 divided by pi times 0.98? 58.5 degrees and that is your angle. Hence find your longer length, the length of your longer arc. So we're trying to figure out what's this length right here. We know that capital R
R plus 128.
is little r plus 0.28. So what's that? 1.26. And then we know to find arc length, it is nothing but theta over 360 times 2 pi r. And we know that theta is that long decimal that you still have in your calculator, correct? So take that long decimal, divide it by 360 times 2 times pi times 1.26, and you should get your length of 1.29 meters, because we don't want to forget our units on any of them. Questions?
How did the R get to the denominator, like, on where the yellow circle is?
Because of right here, when you were multiplying 0.28, 180, and 2r together, there's still that dividing by r there from back here. So then you'll basically have a 100.8 r all over r. That's how they end up canceling out. And since it's dividing by 360, that 360 is still in the denominator as well. Okay, let's keep going. You guys give this one a try. The logo for a company that makes chocolate is a sector of a circle with a radius of 2 centimeters shown as shaded in the diagram. The area of the logo is 3 pi centimeters squared. The diagram is not drawn to scale, but the figure, the logo is, what type of figure besides Pac-Man? Is it what? Is it what? It is a sector. Okay, a sector can be basically any piece of a pie. Doesn't matter how big. It doesn't have to look exactly like a slice of pizza. Okay, so if the area of this particular sector is 3 pi, then that means that we know, well, what's the formula for area of a sector?
Theta over 360 times pi r squared.
True. But since it asks us to find theta in radians, we need the radian formula. So what formula is that?
1/2 pi r squared theta.
1/2
1/2 r squared theta.
r squared theta. What's the radius of this circle? 2. So this becomes 3 pi equals 1/2 2 squared. Now theta in the formula does not represent this theta because this theta is not in the sector. How do you represent this theta, the one that's actually in the sector?
2 pi minus theta?
Say it again.
2 pi minus theta?
It's 2 pi minus theta. First off, where'd you get the 2 pi from?
360 is 2 pi.
360 is 2 pi as a radian. And so since you already know that part of it is theta, right? You just subtract. So we're going to plug in for theta is 2 pi minus theta. So what's 2 squared?
4.
What's half of 4? So this becomes 3 pi equals 2 times 2 pi minus theta. If I distribute that over, that gives me 4 pi minus 2 theta. Subtract 4 pi from both sides, and you have negative pi equals negative 2 theta. So theta is pi over 2.
Do you have to do that with theta?
No. You can do a different one. How did you do it?
I found the whole circle and then I divided the fraction of, like, I did 3 pi over 4 pi.
Mm-hmm.
And then I saw it was 3/4 of it, so then I did pi. I had to do that. The other one was 1/4, which would be 90 degrees, which is pi over 2.
Good way to recognize it. Now I have to find the total length of the perimeter of the logo. The perimeter of the logo consists of this part here, which is represented by what? It's represented by the arc length. So I need the arc length formula, which is r theta, because we are in radian. But it's not just the part that's on the outside, it's also 2 radii. Because this is technically all the way around the figure. So now we have 2 radii as well. What is the radius of the figure? 2. And what is theta in this problem?
3 pi over 2.
It is going to be 3 pi over 2, because if theta is pi over 2, that's nothing but 2 pi minus pi over 2. Common denominator, and then you get 3 pi over 2. Plus 2 times r, which again is 2. What's 2 times 3 pi over 2? 3 pi. And then what is 2 times 2? So then plus 4, and this is in centimeters. Questions? Okay. Let's take a look at this one. Okay, so we are told that the following diagram shows 2 intersecting circles of radii 4 and 3 centimeters. The center C of the smaller circle lies on the circumference of the bigger circle. So if you have the smaller circle that has C as the center, that means its radius is going to be what?
C is
3. So that means that BC is going to be 3, just like CA is going to be 3, because those are the radii for circle C. Then it says, so then that means the bigger circle, which has circle O, because it says O is the bigger circle. Then the radius of O, which is OC, would be 4. Now it's asking you to find angle BOC, which will be this angle right here. How long is BO? 4. So you can either use law of cosines to find that angle, or since you can recognize that, what kind of a triangle is BOC? It's an isosceles triangle. You could draw a perpendicular to the opposite side, and only in isosceles triangles, just like in equilateral triangles, that height is going to do what to that side of 3? It's going to bisect it, so this becomes 1.5. So then you can find this angle right here using SOHCAHTOA, and then just double it to find the angle. Either way. So law of cosines to find the angle using the orange triangle, or SOHCAHTOA to find just the half and then double it. Since I already drew in my right triangle, I'm going to use sine of that angle equals 0.5 over 4. Theta is going to be equal to the sine inverse of 1.5 over 4, and then I'm going to multiply it by 2 to get actual angle BOC. Can somebody do that for me and tell me what it is? Sine inverse of 1.5 divided by 4, then multiply that by 2.
44.05.
So 44 point.
Oh, 44.0.
Now, okay. Okay, so then, can you guys do that in radians? Change your modes to radians and tell me what this is radian. Do the same thing, just on radian mode. double it?
Oh, it's 0.76.
7.6 what?
9.
So 769 as a radian. All right. The area of the shaded region now. Now, what do you know about those two shaded regions, BC and CA? They're equal. So if I can just figure out one, then I just have to double it to find the full area of the shaded region. And that little shaded region is known as a not an arc length,
A sector.
not a sector.
A segment.
It's a segment. And to find the segment, you need to find the area of the.
We already have theta, so we can find.
So we can find it by doing the area of the sector, subtracting from the area of the triangle, and then of course we want to double it to get both of them. The sector. I mean, we have both in degrees and radians, and I had to do it both because I don't remember what the Lamar scheme wanted it as an answer. Oh, they accepted either. Okay. They accepted either.
If it doesn't specify, will they accept either?
But again, if the problem is gives you an angle in radian, you probably want to work everything using the radian formulas. And then also, like I said, I don't know. I think they only give you the radian formulas in the reference booklet, not the degree ones. Let's see. So for the sector, the radius is 4 squared. I'm going to multiply that by theta, which is the last thing that you guys should have in your calculator. Then I'm going to subtract the area of the triangle. We already know the area. Well, we have the triangle. What's the base of the triangle? 3. Oh, we don't have the height, though. What's the other way we can do it? Let's
Use the perpendicular.
I could use the perpendicular and find it. Or I can use the one that has the sign involved.
Yeah.
Half the product of the two sides, so 4.
Times 3 sine whatever.
Sign of that angle that you just found. You want to use 4 and 4, not 4 and 3. Because 4 and 4 are on the sides of that angle that you just found. So once you figure out what the segment is, then you'll just multiply your answer by 2 to get the area of the shaded region. What is it? 1.18? Thank you. Let's take a look at this one. In the diagram below shows a fenced triangular enclosure in the middle of a grassy field where AC is 3, DC is 2, and angle ABC is alpha radians, and BCA is pi over 3 radians. One end of the rope is attached to point D on the outside edge of the enclosure, and the other end is attached to a goat at G. Given that the rope is 6 meters long and the area of the field outside the enclosure that the goat is able to graze is 74 meters squared, you have to find the value of alpha. Okay, now if you tie up this goat, or if you even tie up any type of creature who's going to be able to, he's only going to be able to go 6 meters out in front of him. That's in any direction. So at that very taut rope, if that goat is going to walk around at his very tight limit to the left or to the right of him, what type of shape is he going to form? Huh? He's going to form a circle. More specifically, he's going to form a semicircle because, for one, if he goes this way, he's going to be stopped by that fence, that enclosure. But if he continues to walk this way,
You can only get so far.
he can only go so far. But no matter what, he's always how far away?
6.
He's always how far away? When he gets here, how far is he away? He's still 6. But how far? Let's see, A, B, C. Let's call this point D. How far is it from C to D?
4.
It's 4 because that's to be a total from. Oh, I already have D here. Sorry. Let me use E. Okay? Because from the point where the goat is chained up, which is at point E, he can only go out to 6 meters for this. Okay? But once he hits that point, okay, now, yes, he's going to now be kind of running against like the other side of the fencing. Like part of the rope is going to be tight. And so now, as he continues to graze, how big is this?
4.
It's now 4 because he can only go 4 meters out, no matter what part he's in, including right here. This is a total of 4. But now at point F, which I'm just labeling, I'm using the letters that are left. How much is it from A to F? Huh?
1.
It's 1. because now like basically the rope is stuck on DC, is stuck on AC, so now he only has just now a little bit of range to maneuver again before he hits that fencing again. Okay? But this entire area, the pink area, the blue area, and the black area, how much is he able to graze? 74 meters squared. So 74 meters squared is the total area between this black shape, which is a what? It's a semicircle. So 74 meters squared consists of the semicircle and what? What's the blue part? The blue sector. And what's the pink part? It's another sector. Okay? How do you find the formula for a semicircle? What is it?
Would have like pi or
Pi r
squared. No.
Yeah, 1/2 pi r squared. And then for the sector, since we are dealing with radians, what's the formula for the area of sector in a radian?
Oh, shoot. 1/2 r squared theta.
Okay? And then the other sector is 1/2 r squared theta. I know the bell's about to ring, but I'm just going to finish this up. Since I know that the radius of the semicircle is 6, I'm going to plug in 6. Since the radius of the blue sector is 4, I'm going to plug in 4. Theta is this angle right here. A straight line. How many degrees is in a straight line? Or what is that as a radian? It's just pi. So this little bit, this purple angle is going to be pi minus pi over 3. So that's what goes in here, pi minus pi over 3. Then we're going to add that to 1/2 the radius of the pink sector, which is a radius of 1. And theta is now this angle. And if you're wondering what theta is, well, first off, I don't know what this angle is. But I do know that when I add alpha and pi over 3 and subtract it from 180, I get this angle. Correct? But this angle on the outside is the angle I want. And that is alpha plus pi over 3. Because if you do 180 minus alpha plus pi over 3, you'll get the question mark angle. Well, I want the one that's on the outside, so what am I going to do? I'm going to do 180 minus that angle that you just did. And those two angles are going to end up canceling out. Sorry, because these are together. Okay? That's how you get alpha plus pi over 3. There's also a formula, the remote interior angle formula, that says if you add those two angles, it will always equal an extended angle. Okay? So from there, you can solve for alpha because you have your equation. So all of this is using those formulas, basic formulas, area, sector area, circumference, arc length, to solve.